In this lab, we will separate the photosynthetic pigments from a concentrated Swiss chard extract using paper chromatography. First, get a strip of chromatography paper. Be careful to handle the paper only by the edges. Use a ruler to measure and draw a line 2 centimeters from the bottom edge. Make sure you use pencil to draw your line. Elevate the lower edge of the chromatography paper before you start applying the concentrated Swiss chard extract. Using a long pasture pipette, carefully apply the concentrated extract to the pencil line. After applying one layer of extract, allow it to dry for a few seconds, then apply another layer. Repeat this about 6 times. Once the extract on the line is completely dry, you are ready to develop the chromatograph. Gently swirl the chromatography jar to mix the solution. Open the lid. Carefully insert the chromatography paper and replace and close the lid. The bottom edge of the paper should be in the solvent, but the pencil line and layers of Swiss chard extract should be above the level of the solvent. Over time, the solvent will move up the paper and separate the individual pigments from the concentrated extract. When the topmost pigment is about 1 to 2 centimeters from the top of the paper, remove the lid and remove the paper from the jar. Remember to replace and close the lid of the chromatography jar. Mark the solvent front as soon as possible after removing the chromatograph. This will be approximately 1 millimeter ahead of the topmost pigment. Your chromatograph should have bands of 4 different pigments. From top to bottom, we have the orange carotene, the yellow xanthophyll, and the green pigments chlorophyll A and chlorophyll B. You may also see a gray band between the carotene and xanthophyll. This is an artifact and will be excluded from our analysis. Starting from the origin line, use a ruler to measure the distance traveled by each pigment and the solvent front. Use these measurements to calculate the RF values for each pigment. Plug in and turn on the spectrophotometer. It needs several minutes to warm up before it is ready to use. While you are waiting, label a set of small flasks and test tubes for each pigment. Carotene, xanthophyll, chlorophyll A, and chlorophyll B. Cut up and combine the carotene bands from all chromatographs made by your group. Put these into the carotene flask. Only 1 chromatograph is shown in this demonstration, but you should have 4 chromatographs per group. Repeat this for each of the pigment bands. Add a small amount of acetone into each flask. Use just enough acetone to cover the cut papers. Swirl a flask to extract the pigment from the papers. Pour the extracts into appropriate labeled test tubes for each pigment. You will also prepare a blank test tube with 80% acetone. A tube of the diluted Swiss chard extract is provided for you. Note that the test tube labels are near the top of the tubes. If they're too low, they will interfere with the spectrophotometer being able to analyze the liquid in the tube. When the spectrophotometer has warmed up, make sure that it is set to measure absorbance. Then set the wavelength to 380 nanometers. Before taking any readings, you need to blank the spectrophotometer. Place the blank test tube with 80% acetone into the chamber. Close the chamber lid and press 0 ABS. Wait until the display reads 0. Remove the blank and record the absorbance values for each pigment sample. Once you have all of the absorbance values at 380 nanometers, increase the wavelength on the spectrophotometer to 390 and repeat the process to get all of the pigment absorbance values. Continue increasing the wavelength by 10 nanometer increments and reanalyzing the pigments at each wavelength. Remember that you must reblank the spectrophotometer each time you change the wavelength.